Hello, in this video let's talk about the limits. So this is the first video on the limits. It's the introduction to limits. What is a limit? In English, the limit means that we are approaching something without actually getting there. So when somebody is testing you and you have an unpleasant experience, you might say that you are pushing my limits or you are testing my limits. What does it mean? That means you're very close to breaking point or to some unpleasant point, but you're not there yet. And that's what approaching limit is. And in math, that's the same concept. In math, the limit is basically what is the y value as x approaches something. And it can approach either a number, which is a point, or it can go to infinity. So there are three types of limits that we'll look at. The limit at one point as x gets to it from both sides, the limit at one point from either side, from the left or from the right, and the limit at infinity as x goes to forever, either to the right side plus infinity or to the left side negative infinity. How to find the limits? There are three main approaches. One is to look at a picture. So if you look at a graph, the first approach is graphical. The second approach is with the technology using the graphing calculator. This method is only good for approximating the solutions. It's not a way to prove that the answer is true, but it's a way to accurately guess what it is. And in some situations, technology approximation is the only tool that we have, because no graphical approach and no analytical approach would do the job. In fact, graphical approach is very similar to technology because we use technology to produce the graph, or the graph is already given to us in a question. Now, the last method is analytical. This one is by hand, and it involves algebra and the definition of limit to solve the question. This one, if it works, it always gives the correct result. It is the actual proof or justification that our answer is correct. So in the example, let's look at our first example, and we will use the limit at a point, and we will use graphical approach. So there will be three different examples in one picture. So below is the picture, here is the graph, and we're interested in limit of our function. This is the function f of x. We don't actually have a formula for it, and that's why we cannot plug it into our calculator, because we don't actually know what expression would give us this result. But with a diagram, we can still answer the question, what are the limits? So there are three questions. What is the limit of our function as x approaches -3? So the x is getting to -3 from both sides. That means we're getting super close to -3. We can picture ourselves walking up to the -3 from the left side and asking ourselves, what is the height that I will approach? And that height is 2 from the left side. As you go from the right side, what is the height that the y will approach? And that is also equal to 2. Since both of these values are equal to 2 from both sides, that means that the limit is actually equal to 2. Even though the value at the -3 happens to be 3, we're not interested at the point. We're only interested as we're getting really close from the left and really close from the right. We're not interested specifically at that location. This is the point that we skip. We're only going from left or from the right. Now let's look at the next example. So here we are approaching 2 from the left and from the right. So as we go to the 2 from the left, we are going on this side, and that height is equal to 1. But from the other side, from the right side, we're going on a different piece of the curve, and we will end at this height, which is 2. So from the right side it's equal to 1, from the other side it's equal to 2. Both of these must match, and if they don't match, that means there is no limit, or the limit does not exist. 0 with a line through it means does not exist. Sometimes we write D and E, which also stands for does not exist. So this limit doesn't work. And the last one is, as we're going to the 9 from both sides. So as x approaches 9 from the left, x approaches 9 from the right, what is the height of that point? And from both sides, it is equal to 1. So the limit is equal to 1. And that is how to find the limit from both sides if we have the picture. It is absolutely important that the height from both sides must be the same. If the height from both sides is not the same, then the limit at that point does not exist. If the height is the same, whether the point is there, or the point is not there, then the limit exists and it equals to the height as the x gets super close to the value that we have indicated. And that is it for the introduction to the limits. If you have any questions on anything, please let me know. And thanks for your time. Take care.